Small bodies P and Q are initially at the points A and C and are travelling with constant velocities. 1 second later P and Q are at these points respectively. Determine the vector equation for the path of P at any time. Okay, so the position vector of P, well, it started at A, so that's going to be 7, -5, 6. Now, in 1 second it moved to there, so its velocity must be -1, 1, -2. Show that the paths of P and Q cross, stating the point of intersection and explaining whether they also collide. So RQ would be, well, it starts at 1, 3, -4, and its velocity is going to be 1, -2, 1. Okay, so let's consider that the path of P, so I need to call it something else, path of, let's call it P1 or something. Let's go 7, -5, 6 plus lambda -1, 1, -2. So this represents the actual path, not where it is at any particular time. And let's say RQ1 is 1, 3, -4 plus mu 1, -2, 1. Now let's look and see if these intersect. So we'd have 7 take away lambda is 1 plus mu, let's call that 1. We'd have -5 plus lambda is equal to 3 minus 2 mu, and we'd have 6 minus 2 lambda is -4 plus mu. And so if we do equation 1 plus equation 2, we'll get rid of lambda. So we'll get 2 is equal to 4 plus mu, which gives me mu is -2. And if we substitute that into 1, we'll get 7 minus lambda is equal to -1. So lambda would be equal to 8. And therefore lambda is 8. So first of all, check in 3. So we'd have 7 take away 8 equals -1, and 1 add -2 is -1. So the paths cross, but the objects are there at different times, since lambda was not equal to mu, so they don't collide. So now we have a third small body, G, stationary at this point. Determine whether G lies in the same plane as the path of P and Q. So what we want is the actual plane that contains these two. Well, these are the direction vectors. So if we want to find the equation of a plane, what we could do is cross those directions to find a perpendicular. So one of the directions is -1, 1, -2, and the other direction is 1, -2, 1. So for the I, that gives me 1, take away 4, so it's -3. For the j, that's going to be -1, add 2, which is 1, but of course we take a negative in that middle one. And for the k, we're going to get 2 take away 1, which is 1. So this is the normal to the plane containing the paths of P and Q. Now, R dot -3, -1, 1 would be equal to, well, let's just take one of these points. So we know that this point here is on the path of P. So 7, -5, 6 dot -3, -1, 1. So R dot -3, -1, 1 is going to be -21 plus 5 plus 6. So R dot -3, -1, 1 is going to be -10. So what about 5, -9, -4 dot -3, -1, 1? That's going to give me -15 plus 9, take away 4. So that is also -10. So therefore G lies on the plane.